Okay, so we're going to go through the process of completing the square. Okay, so we have a question here. It's written in function notation, but you know, if writing this as y is simpler for you, it's the same idea. We have a quadratic equation, and we know that because the highest power variable is the power of 2. So the variable with the highest power, I should say, is the power of 2. So completing the square, we're going to draw a bit of information here. I'll write it as f at x since we're in function notation.
Yeah.
We're starting in this form here, and this form here happens to be standard form. Okay, so this should be a pretty common form we're pretty used to at this point in the course. The goal is to get, oh, that might be a little too low. Sorry. A little higher up. The goal is to get to f at x is equal to a x minus h squared plus k. And I'll write those two other ones in. And this is known as the vertex form. So completing the square is going from standard to vertex form. The question is, how do we go through that process? How do we do that? Okay, so I'm going to rewrite this question again just below. h at x is equal to negative 5x squared plus 20x plus 7. The very first thing we want to do here is we want to factor by grouping. We want to common factor the a value out of the very first two terms. So here's term 1 and term 2. We're going to common factor a. And a in this case is negative 5. So we're going to take negative 5 out of both of these, okay? When we do that, the negative 5 ends up in front of a set of brackets. And we're left with x squared minus 4x plus 7. What's the key here is when we common factor, we just got to make sure that our x squared is to the coefficient of 1. That's what we're trying to set up, okay? Once we've done that, you can make an argument that our b value has changed. Our b value is negative 4. So there's this little formula, because this is technically an algorithm, a process to doing something. Our new b value has to go through this little formula. And this formula is going to tell us what to add and subtract, okay? So we take the new b value, we divide it by 2. We square it and divide it by 2, actually. I think that's b divided by 2 squared, sorry. We divide it by 2 and then square it. So we get 4 divided by 2. All right, we know that's going to end up as 2 squared, which is going to end up as 4. So what we're going to do is we're actually going to add and subtract 4 within the brackets. The reason we do that is because when you add 4 and then subtract 4, you actually insert or add or subtract 0. And doing that doesn't change an equation. But what it does do is it allows us to make a special case for factoring. Okay? So I have x squared minus 4x. And like we said, we're going to add 4. And we're going to subtract 4 within that set of brackets. And we have plus 7. Okay? And that's just that concept I was talking about. Add 4, subtract 4. It's technically like adding 0. So this is completely fine. We're still balanced an equation because I can add 0 over here. We're still balanced.
Yeah.
The next thing we want to do is this negative 4. We just want to remove it from the brackets. We want to take it to the outside because we only want to have 3 terms in the bracket because we're actually making a perfect square trinomial. When we take it out, we just have to remember that we have to multiply by whatever this coefficient is here. So we have to multiply by that negative 5 when it comes outside the bracket. So we get negative 5 x squared minus 4x plus 4. And then negative 4 times negative 5 gives you positive 20.
Wait, how come it's add 4 and then minus 4?
Because when you add n minus 4, it's the same as adding 0 to an equation. And that still keeps an equation balanced. Because technically when we put something to one side of the equation, we must do it to the other. What's neat is this is like adding 0 to one side. So I don't actually have to do anything to the left side of the equation. If I had only added 4, I would have had to add 4 to the left side of the equation. There has to always be balance in a mathematical equation. Okay? So by adding and subtracting 4, it's the same as adding 0. So I don't actually have to do anything to the left side of my equation. That's a very good question. So now that we've done that, we've created a very special case here. Okay? This is a perfect square trinomial. And if you recall, the way to factor a perfect square trinomial is you just take the square root of the first term and the square root of the last term. Okay? And we're going to take the positive values. Technically, there's two answers when you square root something. The square root of x squared is x. Square root of 4 is 2. And what's neat about it, okay, we have negative 5. We're just going to write this as a single bracket to the power of 2. We're going to put in the x and the 2. We're going to take the operand or the operation in front of the middle term, which is a negative, so x minus 2 squared. And then finally, the very last step here is to add these last two things. Well, that becomes 27. And what we've now done is we've gone through a process where we have our a value for vertex form, we have our h value for vertex form, and we have our k value for vertex form. So this is the process of completing the square. This is an algorithm. You go through all of these steps, and it'll put us in the specific form called vertex form. Okay.